Yeah, first to introduce myself, I'm Raph, or RaphJaph on the internet. I'm the lead maintainer of the Ordnance protocol, and yeah, originally for this talk I had planned to do something, talk about something in the Ordnance protocol or the Runes protocol, but this is a hackathon, so I thought I'd do something a bit different and kind of share with you guys some kind of tools and techniques that Casey and myself used to create two somewhat successful protocols. So yeah, feel free to ask any questions. It's going to be a little bit interactive. We'll see how it goes. Yeah, this is also like highly opinionated talk. So for every point I make, I can think of counterpoints. So take it with a grain of salt. It's more something you want to strive towards. It's non-dogmatic. So yeah, metaprotocol. I mean, it's funny. Calling something a metaprotocol is a bit funny because the word meta just kind of is a reflection of you not knowing what it is yet. So if you think of the internet, like if you have UDP and TCP, you don't really call HTTP a metaprotocol, but theoretically it is. So everything's layers. Like in computer science, you always have these layers. Like you go up and down the abstraction ladder, and everything is a metaprotocol of something else in a sense. And yeah, calling something metaprotocol is more a reflection of the unknown, that you're creating something new. Basically going from 0 to 1. Like there was nothing there before, and now you have something that works. And this is kind of, if you're trying to create a metaprotocol, this is the domain you're working in. You're going from something that didn't exist before to something that exists. You're not in this domain. You're not like trying to scale something out. Like for example, Ordnance, you're not trying to build, we didn't try to build a marketplace or a wallet. Like we tried to keep it very simple, kind of going from nothing existing to kind of something existing. So yeah, and I'll come kind of back to these two because oftentimes I see people think, they're trying to create something in this domain, but then they kind of slide into this, and this is where like premature optimization comes from, where they try to like, oh yeah, I'll do this and that, and then this is how you kind of lose progress, how you kind of slow down. Like you have to really kind of always pull yourself back and be like, okay, I have to focus on what is like the essential part of what I'm trying to create. Yeah, the first, and I think the most important aspects of creating and coding and coming up with something new is what I could just call loops and iterations. I have this very beautiful drawing of my. Basically, it's you're trying to create these loops. There's two basic loops you're trying to create. Like the first one is your dev loop. Like when you code something, when you have an idea, how do you verify that idea works? And the second important loop is if you want to go to one, like if you want adoption, if you want people to use it, is like what is the user loop? And if you design your dev loop correctly, like if you have a nice feedback loop, the type loops, like if you could like iterate really quickly, the kind of user loop will kind of flow out of that and will bleed into that and make that also kind of better, because you have these nice like tight loops, tighter loops, faster laps, that's kind of the idea. And example here would be, so the small loop, when you start creating a protocol, maybe you start with like defining some types, and then you write your unit test. That's the small loop. You kind of write something, you see like, oh, the tests are passing. Now I can go and maybe write an integration test. So now you have this bigger loop, and then maybe something fails in the integration test, and then you go back to the unit test. So you have like these loops, and you try to like always go bigger and bigger, and then all the way at the end, you have like the whole loop where you maybe like, okay, now I'm going to do a Bitcoin transaction on mainnet and like go through the whole cycle. But oftentimes people try to go all the way to like, oh, I'm going to test this directly on mainnet on Signet, and then this feedback loop just takes long. Like a Bitcoin box takes 10 minutes, so now you wait 10 minutes for like something to go through and then verify that it works. So if you kind of go to this big loop first, it'll slow you down. Like it looks like a shortcut. Oh, I'm just going to go there. I'm going to make this, test this on mainnet. I just want to verify. Going there directly will kind of slow you down in the long term. You always want to have like build up slowly. You want to build up momentum. That's kind of the basic idea. And yeah, so an example of kind of how you have these quick feedback loops is when we develop, like we used a lot of, like, testing was kind of the bedrock of this. So we would, if you think of ordinals, kind of the base kind of idea is the idea of like numbering Satoshi. So giving a number to a Satoshi. So the first thing we kind of did was like, okay, so let's look at the base kind of thing we have. Oops. Source creates source. So the base idea is like, yeah, okay, so we create this. We have now, given this Satoshi a number, let's, try to play around with it. Let's see what this type actually is. So a SAT is just a U64. And then you can see from here, we, define a SAT. We have all these like different representations of a SAT. And then all the way at the bottom, we have like a bunch of unit tests, like where we like to test everything, like all these kind of things. And this is what, this is the first kind of small little feedback loop. You've come up with an idea, and now you want to kind of test that this idea works. And it's the, one of the smallest units. And then you kind of can just iterate through this. You're kind of building up a mental map in your head about how this works. And you can kind of see, you build these tests, and then this is like your smallest loops. And then the bigger loop is then, okay, now you have like a SAT. Let's, inscribe it or something. And then you would want to look at how it looks in HTML. So we have like these templates. So then we kind of define these templates, sets, HTML. And then so first we unit test, we in pure Rust, and then we go to HTML. We're like, okay, let's see how this looks on a web page. And then we define like a very simple HTML template, and we're like, okay, this is how it's going to look for the user. So this is a bigger loop. And then, so this is kind of, this is like one of the loops.
Can you plus your font?
Okay. So yeah, the main point is like, you want to have these loops, and you want to slowly kind of build up from there. Let's see what else I had here. Tests are basically also kind of your compass, or you kind of view into the code. Like, you need to have something to grasp onto, like that directs you, and tests kind of direct you towards that. Let's go on to the next one. Yeah, so this is also kind of an important one, owning the implementation. So creating metaprotocol is not creating a blog post, it's not creating a white paper. You see it with Satoshi. He wrote the white paper after he created the client and the implementation. So the basic idea is if you do not own, like if you haven't written an implementation, you don't have a metaprotocol. Like, an idea is not a protocol. And owning it means many things. That means you wrote the code, that you also can run the code, and that you control the code. If it is not packaged like that, you don't get anywhere. And it also has some other adverse side effects. If you are the one who only wrote the blog posts, you lose control. An example is, for example, BRC20, a very successful protocol. But the initial creator, Domo, he started off by writing a blog post and kind of just outlining the system, but he didn't write any indexer. He didn't write any way to kind of use it. And then a different team, Unisat, kind of took that idea and wrote the indexer, and kind of he lost control of his protocol through that. And that led to the situation, this is not known very widely, but the BRC20 protocol almost forked and failed because there was a big rift between Domo, who was the creator, but he didn't own the implementation, and Unisat, who did all the work of creating the indexer. It was back in the time, I don't want to get too deep into the details here, but it was with the Jubilee, there was new inscriptions being recognized as such. Domo, not having an implementation, he just declared, oh, I'm declaring the freeze. So he just declared out onto the internet, I'm going to declare this a freeze. This is what we want to do. We want to freeze to ORD 0.9 or something. But Unisat was no, we don't want to do this. This makes no sense. We want to stay in line with the main indexer, because we depend on it, because they knew the underlying system was ORD, and that was they actually implemented it, so they were aware of the complexities. So they almost broke apart, and then Casey had to broker basically a deal between them. They were so at each other's throats that they weren't talking to each other. So Casey sat down with Domo for an hour, sat down with Lorenzo from Unisat, and then Casey came up with a solution called the vindication charm, which basically then allowed them to like come back together and like avoid a big issue for them. It's not known, Casey just give a fuck, just so it doesn't like advertise it or anything, but that happens if you don't own the implementation. Like, it's very important that you kind of own the whole chain. And as part of that, especially in the beginning, you want to become a sort of benevolent dictator. It is what it is. That Ordinals is still kind of benevolent dictator kind of situation. And, at some point, that's also what Satoshi was in the beginning. He just made changes. And at some point, when stuff matures, of course, you want to relinquish that power like Satoshi did and give it to the community. But especially in the beginning, it's important that you have control. So if you kind of try to create a metaprotocol, own the implementation is what I would say. That's my point on that.
That's good.
So now, I already kind of touched on this before, tests. Tests, very important. So Dream, tests rule everything around me. When I first started working with Casey on Ordinals, he made me write tests for 2 weeks straight, 8 hours a day. All I did was write tests. And the reason this is so important is it goes back to the point of the loops and the feedback loops. You need to know what your code is doing, and you need to test every tiny step. Because if you glance over the tiny things, then the big loops will fail, and then you lose time and you have to go back to the beginning. So you want to have like these tests that run quick and fast and have this nice feedback loop. Just to show you like a very kind of concrete way we kind of developed is that we have this, we would have like something open. I don't know, I'm just going to open this, and then on this we had jwatch test minus. Let's just do roots. We would have like a watch command that runs the tests. We would make changes on the left-hand side, like change something, and on the right-hand side you would have the tests, and either it wouldn't compile or the test would fail, and then this is like a very tight loop. You would see like your tests running on the right-hand side, and you would like make your changes on the left-hand side. I even have my editor set up with cargo limits, such that if there's any compile errors, it jumps. I can, in my editor, jump to that error directly, so I don't have to like copy out lines and find anything. So it's a very tight feedback loop, and tests is your compass, your insight into code, your goggles. When you start developing, start small, like build up the system from the ground up. The first thing you want to try to find is your feedback loop. What is the smallest loop that you can find to kind of create your protocol, and then you build up from there. I think our code base, the Ord code base, has over 2,000 tests, ranging from unit tests, integration tests, like we have the whole chain. Casey was a very kind of test Nazi in that sense. I'm glad he forced me, to write those tests. And tests it's work to do, but it will pay off in the long term. It'll save you a lot of time. It's upfront costs that is worth paying, I would say.
Is J an alias on your terminal?
Oh yeah. So
what
I'll go into this later. Like this is one of my slides. J is an alias for just.
Oh.
And just is a kind of like a make file, much simpler. Also written by Casey. This part of my slides as well. I'll go into just because it's also part of iteration and loops. Like you want to have this fast. Then tree part 2, types rule everything around me. So I would recommend using a programming language that has strong types, but it's not always the case. But types are your basic building blocks. It's the smallest unit. It kind of also ties into this comes from cooking, from French cooking. It's called mise en place, meaning you have all of your stuff ready to go, and then you compose your dish once you have all your little ingredients and all your other stuff prepared. And types is kind of that. So types is like cutting up your carrots and onions before kind of creating the base building blocks that you need to iterate and continue onwards. An example here would be I think I already showed this. Yeah, if we go to source, if we go to kind of the SAT. So like, yeah, we have a SAT. A SAT is just a number. We have all these abstractions around these SATs, and we have another type would be, for example, the degree notation. If we go to the degree, you can see like there are all these types, and these are also all tested. And then we have we have a rarity. There's some rarity. We have like defined these nice types. We're using the type system as we're supposed to. It's all encoded. It's tested, and these are kind of your base units. And once you have this in place, once you have your types, once you have your tests, then you build up from there, and then you compose them together into a more complex software. So, have your shit in place, mise en place. Use the compiler. Compiler is your friend. If it doesn't compile, that's your first error. If your test fail, that's your second error, and then you go kind of from there. You have these small loops, and then you get larger loops and iterations. Okay, this is another maybe more controversial one, but dependencies are not your friend. So what I mean with that is dependencies in a very kind of broad term. I don't necessarily mean, like in my cargo toml, I don't necessarily mean all the crates you have here. I mean more kind of when you start using multiple different languages, or when you start communicating off process boundaries, like you have to start all these different processes to kind of test your thing. Like all of a sudden you're going to put Postgres, and now you're going to have Redis, and then you're going to do like some Lambda functions, and all of like you're calling some APIs. Like the more dependencies you have, the more easily the larger your loops get, and the more more shit can break down the road. So it's very important to kind of boil down, reduce the amount of dependencies you have in your system, especially in the beginning, because again, like you're going from 0 to 1, like you're not trying to scale this. Like maybe if you're having to scale this, you need some Redis or whatever, or Postgres, but like in the beginning, you're in the 0 to 1 phase, you're trying to like be fast, you're trying to like iterate, and you want to understand your system. And the more different systems you have to interact with, the more kind of errors seep into, and also like non-determinism also seeps into it more easily. So dependencies. So I mean dependencies in a very broad term, and dependencies, and this of course is a spectrum. You need some dependencies always, like you're always depending on something, but strive to minimize those is what I would suggest. In board, let me just check the time. How much time I have? So in Ord, we kind of took this to the extreme because we decided we only want to work in Rust. So down from the database up to the HTML, everything's in Rust. I showed you kind of the template stuff before, like the SAT one, for example. This is a templating engine that is also written in Rust. It's called Boilerplate, also by Casey. He literally sat down, was like not happy with other templating engines. He was like, I want a Rust templating engine. And you can see it's templating in Rust, so it's actual Rust code, self.sat. And like this is actual like Rust code inside of HTML. So like we decided like we want to do everything in Rust. So he created a templating engine in Rust. So this is kind of going to the extremes. You don't have to go this extreme, but it really helped us keep everything very tight because everything's in Rust. The same with our database. Index.rs. So for the database, we also decided to stay in Rust. We used ReadyB because you can use Rust types. Because as soon as you have to communicate over process boundaries, like let's say you take an SQLite. SQLite has a very small kind of set of primitives. For example, they only have I32s, I64s, and then you want to use U64s in your code, and all of a sudden now you have to translate between these two types, and they're not perfect translations. Like the U64 is can represent more numbers than an I64. So as soon as you start like translating and going in and out of different systems, you bugs creep in and stuff like that. So this is another kind of example where we took this to an extreme. Is like, we wanted a pure Rust database, so we used this. And also, when you're developing, try to like in the beginning, just do stuff in memory. Don't think about the data. Like if you can, as soon as you add a database, it's gonna like be more complicated. Like try to stay in memories, try to stay in your programming language as long as possible, and then only when you really, really need it, then you add a database. Cool. I don't know why I have this in here. Just is a must. So I mentioned this before. Just is a great tool to have in your tool belt. Every time I download a repo and it has a just file, it fills my heart with joy. Let me just show you kind of what that means. Just file. So just is also a tool by Casey. It's an amazing tool. I can recommend kind of learning it. It's a command runner. It's just a command runner. So you can like define recipes, and these recipes then execute like small things you need in your development environment. The basic way I would like think about this is like you're downloading the repo, you're entering into the repo, you open the just file, and basically what you're seeing is like the person's or the developer's like workshop. You're seeing like tools that they use most often, and you can just take them for free. You don't have to go out and buy it. This is all software, so you can just download it and use the same tools, the same things that we use to develop. So it's like walking into a workshop and seeing what's up. And so when you, for example, download the board repo, you can see kind of most of the time I try to put like stuff I use most often at the top of the file. So you see here the watch command I executed before is cargo watch, which recompile whenever you change something, and then you can like by default it runs the test, but you can also add something else to it. For example, I use ltest, which is cargo limit. I don't use the normal test. Then you can also see how we have our like CI. You can run the CI locally, like it runs the formatter, it runs Clippy. We also have our deploy stuff in here, so you can kind of see what the developer of that repository uses most often, and it gives you kind of a great starting point. If you're like, okay, the first thing I mostly do when I download a repository is I run the tests, or I run the things that I find in a just file, just to like get a feeling for the code base. And you can see like as we go down, it gets more and more kind of. We have our fuzz test in here, so if you run our fuzzing, like you can also run the fuzzing. And these are complicated. It took us time to figure out, okay, this is the commands we want to run. So like, I don't want to remember like which cargo command I need to use. I want to encapsulate it into a nice like small snippet. Try to use Rust and try to use just and kind of just, I recommend just downloading the order repo. It's like filled with gold. I always go back to the order repo and like, how did I do this when I work on a new project? And then I literally copy stuff from the order repo, copy just file recipes and stuff like that. Yeah, you have a question.
Just-L.
Oh yeah, exactly. Just has like, wait, so many. Just dash list.
Or just -L.
Just dash -L. You can see like all the commands. You can also do just -C. Oh no, wait, just choose. Yeah, exactly. Just choose. I have it aliased. Just choose. Yeah, exactly. Just choose. So now you have, if you have fuzzy find installed, you can kind of go through the recipes one by one. You can see them on the right hand side. You can walk through them. Like it's a crazy good tool. Like there's a bus like just help. It has like so many things. Just is a must. And then this is my kind of last point, and this is the one I feel most least confident about, like mocking. Mocking meaning it's kind of part of your testing strategy is you mock an external system in order to we did it because we wanted a faster loop, we wanted a tighter development loop. So what we did is we mocked Bitcoin Core because we have 2,000 tests and we were annoyed that we had to start a Bitcoin node for every test, and it takes a while to start a Bitcoin node, so it was running way too slow. It took multiple minutes to kind of run through all the tests. So after the 2 weeks of me writing tests, the next task I had was writing a mock implementation of Bitcoin Core, and we kind of encapsulated this in a subcrate. I'm not going to show it, but yeah, mocking can be helpful, but it should be used very sparingly because I'm going back and forth about why this is good, because when you mock something, you're not necessarily actually testing against the existing system, and you're trying to replicate the other system, and trying to replicate another system, you're going to have bugs in your implementation. So then it becomes at some point unclear, did I actually test something, or did I only test my understanding of the system, but not the real system? So, yeah. In our case, it made sense. I'm happy about the mock that we did, the mocking, but it's not always the solution that you're kind of looking for. Yeah, to kind of, wrap it all up, these are kind of the, I think, 8 points I had. First one, loops and iterations. That's the most important part. Be quick, have your iterations, tight loops, and then you slowly build up from there. And you have stream, test rule everything around me, types rule everything around me. You want to own the implementation. If you don't own it, then you lose control, and you also don't understand your system if you don't own it. Yeah, mise en place, start with your types, start small, build up from there. Keep your dependencies to a minimum. Yeah. There's always stuff that creeps in dependencies to a minimum, because as soon as you start having multiple different languages and multiple dependencies, your system becomes complex, and you don't want complexity. You want emergent complexity. You don't want inherent complexity. So try to keep it as simple as possible. Layers. Yeah, this was an old slide. We don't have this anymore. And then just as a must. Look at the org repo, look at the just file, and try to integrate it into your workflow. And then the last one, think about mocking, but don't overdo it. Thank you for listening.
Taking questions?
Yeah, sure.
So, earlier, you mentioned a database I wasn't familiar with that was written in Rust to keep the types the same and help with sanity there. Have you, writing a good database is tough. Have you seen any issues not using something like a Postgres or SQLite or whatever? Or has there been, was it worth, have you seen any pain? Is it worth it? I'm curious on that trade-off that you made.
Yeah, so the trade-off with ReadyB specifically is that there's no tooling around ReadyB. It was created by a friend of Casey's, and we are the main user of ReadyB at the moment. But it is extremely performant. We couldn't index what we index with Postgres. It's almost impossible. I mean, it is, but then you're running it on a big machine, and it takes days to index. The downside is you don't have any tooling around, so you don't have any insight into it. So you can't just open a ReadyB file and what are the tables? There's no way to kind of look at the database. So the downside is that's why you need a test for it, because we have no insight into it, so we have to write a bunch of tests around it to see what is happening in the database. I'm very happy with ReadyB. I've worked also now with Rust and Postgres, and then you're translating between Postgres types and Rust types, and that's another thing I hate doing because the types are very primitive, and then you write these translation layers. You can't take your Rust types and just plug them in, so the way you have to translate between the Rust type and the Postgres types. So overall, I say I'm happy, but yeah, it comes with downsides. But in our case, we had to use ReadyB because the performance. Like you could have maybe used RocksDB. It's a bit more mature, but it's, I think, less performant than RaphJaph as well.
Just to plug just a little bit more, something that we do is across all of our repos, we have a standardized set of just recipes. So any repo internally that you check out, it has a just bootstrap target that will like install dependencies or set up like Docker containers or something. We have just test, we have just build, we have just CI. So if you're like working in a team and you want to have maybe uniform build and testing and deployment tooling, like Just is really, really good for that. So just use Just.
Yeah, check it out.
Just
Just sounds pretty cool. Is there other Rust related tooling that you found particularly useful for this stuff?
Yeah, Just is cool. I mean, Cargo is an amazing kind of ecosystem. So I use, for example, Cargo Limit, Cargo Watch. Cargo Limit is a way for me to, if there's a kind of error somewhere in the code, the compiler spits out the line number, but then I am copying the line number and trying to jump to the code with Cargo Limit. I have a, little in any of them config, I can just jump to that error. So if there's a bunch of compile errors, I just jump through. For example, this also makes refactoring very nice because I refactor a type and get like 50 so errors all over the code base, and I just jump through them consecutively and change it everywhere. So yeah, Cargo Limit is also a nice thing to use. Let me just check the just file. There's some stuff in there as well. But format Clippy is your friend. Like, yeah, just like the normal kind of Rust kind of ecosystem things are very good. Clippy is amazing. Like I can even type Clippy errors into my NeoVim and then jump to that directly. So yeah.
So what do you see developers these days doing that irks you the most?
Not writing enough tests, I guess. Or if I download your repo and I run the test and they fail, I'm like, why is this in master? Your test should like fail on master. Also, I'm annoyed when they use too many different languages. So you have something in Rust, but then you're like, oh, I'm going to write a small little Python script to do this for me, and now all of a sudden I have to install Python dependencies, which is a whole fucking thing. Just like test your thing. Now my whole Python shit is messed up. Having too many different things that I have to think about.
And your thoughts on AI tools, agent tools?
Oh, I mean, on AI tools, I mean, I use AI, to help me ideate, but I've never been like this. What is this thing called? Like where you just like go into the terminal and then like code this for me, and then it like codes the whole repo. But there's these codecs or whatever it's called, or
Cursor?
Claude Code or something like that, where it's just like you prompt it and then immediately writes all the things. I mean, maybe that's helpful, but I found them like some weird errors like creep in because it's just like vibe codes and then it works. It looks like it's working, but like it breaks down the line. Over there.
As someone just getting into like learning Rust and wanting to develop on Bitcoin, do you have any resources that would be useful for me to look at?
Yeah, the reward repo, honestly, because you can look at the tests, you can tweak tests, like tweaking tests is kind of like writing tests, and tweaking tests is a great way to start. I started learning Rust. I just went through the Rust book for the basics, took 2 weeks, just like worked through that, did some exercises.
I think if you look through the old Web5 materials, somewhere I gave a drunken guide to Rust programming, and then there's a lot of stuff that's like you should do when you're writing Rust. There's a lot of stuff that you can just do and still be correct. And it's like those things are like usually pretty good if you're just starting out.
The time-proven way of learning Rust is also re-implementing util tools in Rust. Like, for example, re-implementing WC in Rust, where you re-implement WC, in Rust. So using stuff like clap. Clap is like a very good way to kind of build these command line tools. So you use clap, you kind of build a very simple command line tool with clap, and then you re-implement some Unix util thing like WC or ping or whatever you want, and you re-implement that in Rust because that's a real thing. You have something that you can like test against. So that's also a good way to kind of just get your hands ready, like implementing something real, re-implementing something real. Yeah.
I think maybe we're over time a little bit, but thank you.
Okay.
Sorry.